In this video, we're going to solve a continuity problem. So we have f of x defined as x squared minus 4 over x minus 2 for x not equal to 2, and f of x equals 0 when x equals 2. Okay, and we're going to ask say if the following statements are true or false. And we're going to have 4 statements. One is the limit as x approaches 2 of f of x exists. The second statement is f of 2 exists. The third statement is f is continuous at x equals 2. And the fourth is f of x has a jump discontinuity. At x equals 2. Okay, so let's go through these one by one. So the first statement, the limit as x approaches 2 of f of x exists. So to solve this, we need to solve that limit. So the limit as x approaches 2 of f of x. Okay? So when f of x is not 2, it's equal to this. Let's plug that in. So we have the limit as x approaches 2 of x squared minus 4 over x minus 2. What can we do to make that look a little easier? We can do some algebra, right? So we can factor the top. That factors into x plus 2 times x minus 2. And the denominator stays the same, x minus 2. So these two factors cancel. And we are left with the limit as x approaches 2 of x plus 2, which is equal to 4. So this limit exists, and it's equal to 4. So that first statement, say if the limit as x approaches 2 of f of x exists, is true. That limit does exist. It's equal to 4. Okay? Let's go to the second statement. F of 2 exists. Sure, I mean, we defined f of 2 to be equal to 0. 0 is a number that exists, so that's an easy one. F of 2 equals 0. True. The third statement, f is continuous at x equals 2. So this one, we need to remember the definition of continuity. Remember, it's got 3 different criteria. A, we have to have f of 2 exists. Well, in the second part of our question, we just showed that f of 2 exists. So that checks out. B, we have to have the limit as x approaches 2 of f of x exists. And that looks like the first part, right? We show that the limit as x approaches 2 of f of x exists and is equal to 4. So we know that this is true. And now we have to check the last part. What's the last part of the definition of continuity? Well, the limit as x approaches 2 of f of x is equal to f of 2. what you approach from either side of 2 has to equal f of 2. Well, in the first part of our problem, we showed that this limit is equal to 4. And we know by the definition that f of 2 is equal to 0. So does this limit equal f of 2? No, because 4 does not equal 0. So this does not hold. Because this one condition doesn't hold, that means the whole function is not continuous. Let's take a look at a graph. Let's think about how we might graph this. Well, we showed that when x is not equal to 2, this function actually just looks like x plus 2. So that's easy to graph. That's just a line. Let's graph that. So we have f of x and x. And we're trying to graph the line x plus 2. Okay, when x is 0, f of x is 2. Goes like this. And then when x equals 2, there's a hole. F of x is defined to be 0. And then the function continues. And this is at x equals 2. So does it make sense that this is not continuous? Well, yes, it does, because if you were drawing this line, your pen would be on the paper, you'd approach the hole here, then you'd have to pick up your pen, fill in this hole here, pick it up again, and then continue on drawing. Since you can't draw it without picking up your pen, it's not continuous. Okay? Let's take a look at part 4. F of x has a jump discontinuity at x equals 2. Well, the graph does jump down, but remember, for a function to have a jump discontinuity at a point, the left and the right-hand limits have to be not equal. And in this case, the left and the right limits are equal. Remember, a jump discontinuity looks more like this. Right? So this isn't a jump discontinuity. This is jump. Is this an infinite discontinuity? Nope, there's no asymptote. Nothing approaches infinity. So what's left? A removable discontinuity. If we redefined f of 2, we could make this a continuous function. If we defined f of 2 to be equal to 4, this hole would be filled in, and when we went to draw the graph, you could draw the whole graph without picking up your pen. So let's just draw that quickly. It would just look like this, where this hole would be filled in at x equals 2. Right, so this is a removable discontinuity. This is a jump discontinuity. And this down here would be continuous. So the statement f of x has a jump discontinuity at x equals 2, that is false. And I guess I didn't write the statement here, but of course for part 3 that is false. It is not continuous. Okay.